You got your parting tool.
Right.
You've got what I call a left-hand tool.
Okay.
Because it goes to the left. That one is more of a screwed up tool. We'll leave it at that. And this is a universal.
Okay.
What we want to do is we're gonna make a nice strong shoulder on the edge. So we want the left-hand tool.
Okay.
Because this is going to be down. It's going to be nice and flat. Okay.
All right.
So that's the one we're going to use. And if you notice, we've got a little bit of a relief angle, so we can actually part off a little bit with this tool.
Okay.
So that's what I plan on doing. First thing I'm going to do is use this one because it's set up for parting.
Okay.
For not parting, I'm sorry.
But for facing.
The first thing you want to do is the most important setting, second most important setting, is the height of your tool.
All right.
Okay? This tool needs to be, the cutting edge needs to be right on center, and it's going to be this way.
Okay.
So if you look down this way, you want that point. You want that point
to line up with this one?
Yep, to line up with that one. And it's... Okay, move your phone. Okay, it's right on there. You got to kind of get yourself level enough to
just get
up.
Okay, I got you.
Okay. So we know we're at 2.5 inches. So 2.5 inches. What's going to be our? You know what surface feet per minute we're going to use.
Surface feet is going to be 200.
200 to 400.
Right.
So figure out our RPM for 2.5 inches.
For using 200, I came up with the RPM of 306.
Okay.
Or do you want to go higher?
We can go higher, but
okay.
306 is fine.
All right.
That would be 325 would be good.
Okay.
Now, one thing you can change, okay, you got your calculator. You've already put in your diameter. You've already put in your cut speed. If you want to change your cut speed to 300, all you got to do is that. And automatically change your RPM.
I didn't know that. Okay.
Okay. Because it stores all those.
Right.
So unless you change them or hit clear twice, it keeps them in there.
Okay, okay.
So if we're gonna go, we'll go with 300. That's 458. Well, look at there, 460. So G L M.
Okay.
Now that's gonna be kind of quick, which will be fine because we're only gonna be at this diameter for a short time.
Right.
And then the diameter is gonna shrink, which means we can go up in our RPM if we want to.
Okay.
Okay. So the first thing we're gonna do is take it up and just touch it like that. And what we're doing is we want to get that surface completely flat. You notice I'm not using the feed.
Right.
Because it's just, and you can, if you look on this side, you can tell that it's not flat. Okay? So we'll come in just a little bit more. And you can use this.
Okay.
Because what we're going to do is, we're using this one because it's designed for this maneuver, for this operation. And we know that we're going to be flat, so then when we move to the next tool, we know we can take a very light cut.
All right.
And be where we want to be. See, that looks good. Okay.
And every time I put a new angle on here, I got to make sure it's
You should, yeah. At least the first time you use it, see how loose that is?
Yeah.
That's what sets your height.
Okay.
So we're going to use this one. How's it look?
It's a little bit above it, yeah.
So now we're going to try to figure out our feed rate. And the feed rates are based on thousandths per revolution.
Okay.
So that is 4.2 thousandths per revolution of the spindle.
All
so
right.
For 100 revolutions, it's going to go 42 thousandths. So 4 thousandths per revolution is really fine. We're going to go with probably go with, see what 10 thousandths does.
10 thousandths a revolution?
Let's go with 7 thousandths. So 8, D, A, D, 8. So that's this. A,
okay.
D, and then 8. And then put this back in. Okay, so now we can always back this off. See how fast it's going. So now what we're going to do, so I want to come up here and just touch it. Just, you see it barely touch it?
Yeah.
Coming about 3 thousandths.
So is this considered fast for like for facing it?
Considered fast?
Yeah.
It's not really that fast. You can see you're getting a pretty good finish.
Finish, okay.
Yeah, that's not very fast at all, actually. But for now,
That's what you want. That's what you want to do, right?
for right now, I think that's where we should be.
Okay.
Until you get more used to it, because you speed up the feeds, everything starts moving faster.
Yeah. I want to get understanding first.
So once you've got it faced, right about there, back this out. Now is where you set your Z, because now you set your Z for this tool.
Okay.
So you zero out your Z. You know that right there is 0. Okay? Now there's a few things that we need to plan out a little.
Okay.
Because we know that we have to do a length from the drawing, total length of the part. We have to figure out the length for the step, and then we've got 2 diameters we have to meet.
Right.
Okay? So we know that this is at 0. As long as we don't change that, we can do our face. So I'm going to make a face, or not a face, I'm going to take a pass to clean it up, because sometimes it's a little bit off center. You know, it's not completely concentric.
Okay.
So if you come up, just touch it. Now you see how that's not. It's not concentric.
Right.
So what we're going to do, we need to turn it down until it's concentric.
Okay.
So I'm just going to zero that for my reference. I want to go in about 10 thousandths. I'm going to let it make a pass. And you can see that it's hitting everything. At least it looks like it.
this is bringing it back to concentricity.
Yes, we're making it concentric. Because of the 3-jaw chuck is not totally accurate. See, now we've gone to 1.7. We know our part only has to be 1.5 inches, right?
Right.
So 1.7 gives us a little extra.
Okay.
Okay? So we're going to come back. I'm going to say that that is not quite concentric. I just don't like that right there.
Okay.
So we'll go in another 10. And this is just so we can get to our starting point.
Okay.
Okay? That looks better. So now we need, what we're going to need is micrometers.
Okay.
Because you just don't get any better precision. They're way better precision. You can use your calipers for roundabout, but the micrometers really do a good job.
All right.
So I'm going to zero the X. X is this way. Z is this way.
Correct.
Sorry, I caught up.
No, you're
So
right.
now we know that from here, we're going to take this measurement. Good. So I go ahead and I move it in. To 109 thousandths.
Do you ever give yourself for facing or anything like that?
Well, the thing is you put it in here at we'll leave it right at that. That's close enough to 1.9. So now 109. So I'm going to zero that out.
Okay.
So now we know that 0 is where we're going to end.
All right.
So no matter where you're at, you know how much more you got to take off to get to your number.
Okay.
No more math.
Yeah.
Okay?
I got you.
We're going to do the same thing with your Z, which we don't have to worry about. We don't have to worry about that with this pass because we know we're going to stop out here somewhere. The number that we're concerned with is the 1.25.
Right.
That's the one that's really going to matter. So now we can go ahead and get this down to our 2.375 and then we'll move on to the step.
Okay.
All right? So now it's your turn.
All right.